All right, in this lesson, we're looking at trigonometric relations. So basically what we're looking for is how one trig ratio can be connected with another one. And so we're just going to have a look at the following true statements for a start, that sine 70 is equal to cosine of 20 and cosine of 50 is equal to sine of 40. So relating sine and cosine here, but the thing is, these statements are true, and how they're related is just by examining the angles here. Those two add up to 90 degrees, whereas these two also add up to 90 degrees. So what I'm going to write here is the angles of each statement add up to 90 degrees, and these are called, what you know, as complementary angles. Okay, this is something we learned again in about, I think, year 7 or 8. Okay, it's a stage 4 thing. Okay, now these sine and cosine ratios that you have a look here are called complementary ratios. Okay, due to the fact that the ratios, in fact, are equal. That means whatever this is equal to whatever this is on the calculator. Okay, so they're equal. However, the angles are just angles that add up to 90 degrees. Okay, so um, to find the complementary ratio of sine, we place a co in front of it, right there, and that will become cosine. Okay, so that's how you find the complementary ratio of sine. And this is when you use it, which is when you're given sine of 90 minus theta. This 90 minus theta can change to theta, and you put a co in front of it, and it'll become cosine of theta. Similarly, the other way can also happen. If you're given cosine of 90 minus theta, you can change 90 minus theta to theta, and just remove the co bit, and that will just turn the cosine back into sine. Okay, so there's a proof for this, okay, of how this kind of works. So, um, right. So the thing is, um, we've got a triangle here with theta, opposite side B, adjacent A, and hypotenuse C for now. Okay. So what's sine theta then? Sine theta is opposite over hypotenuse. So that will be B over C. Whereas cosine theta is adjacent over hypotenuse, which is A over C. Okay, so we've taken advantage of the theta here. What we're now going to find out is what sine of 90 minus theta and 90 minus theta is. So that angle can be found right there. That's a missing angle, and you can find that by just getting 180 minus these two angles. So I'm just going to put that right there. But 180 minus 90 is going to be 90, whereas I have to chuck in that minus theta at the end. So there you have it. It's 90 minus theta. So if I do sine of this angle instead, which is now 90 minus theta, that will be opposite, which is A, over hypotenuse, which is C. So I'll have A over C. Cosine of this angle is now going to be adjacent, which is B, over hypotenuse, which is C. Okay, so you can now see that sine of theta, which is B over C, is equal to cosine of 90 minus theta, which is also B over C. Okay, hence this statement is true. Whereas sine of 90 minus theta equals A over C equals cosine of theta, which is also A over C, which means this is true. Okay, right. Let's have a look at applying what we just learnt to question 1. So find the value of each pronumeral here. Okay, I'm just going to put this here. Okay, so sine 35 is equal to cosine alpha. Well, the sine has been given the prefix co, so now what we're going to do is get 90 minus that angle, and that will be the size of alpha. Okay, right, so we're just going to follow basically this rule here. Okay, so you've got an angle there, which means that the other angle, which is complementary ratio, should be 90 minus that angle. So alpha will just be 90 minus 35, which is basically 55 degrees. Okay. For this one, we've also got the complementary ratios, cosine and sine. So beta here should be 90 minus this angle. So 90 minus 21, which is 69 degrees. Okay, these are also complementary ratios. Okay, so here we have gamma. So gamma is written like this. Okay, and it is equal to 90 minus 82.81 degrees. So 90 minus 82.81 is going to be 7.19 degrees. We're going to do the same thing here. These are complementary ratios, and 90 minus the angle here should give us the value for phi. Okay, so phi would equal to 90 minus 27.5 degrees. 90 minus 27.5 is 62.5 degrees. Okay, for A, theta would equal to 90 minus 25 minutes, 12 degrees. And just remember to pop in that degrees, minutes, seconds button on your calculator whenever you're typing any kind of degree or minutes. So 90 minus 25 degrees, 12 minutes is 64 degrees and 48 minutes. Okay, so again, if it comes up as decimal on your calculator, press this to adjust it so that it shows degrees and minutes. Right. Question 2. Find the value of x. Okay, so we've got cosine of some angle equals sine of some angle. So these are complementary ratios. Okay, now what I can do here to make this simple is I'll leave this alone for now. So cosine of x minus 20 we'll leave alone. But you can adjust sine 40 and turn it into its complementary ratio by adding co in front of the trig ratio. That becomes cosine. Then simply changing 40 to 50. Okay, and how we do that is just getting 90 minus that answer. Okay, 90 minus 40 to get the complementary angle. Okay, hence we have found out the complementary ratio to sine 40. So once we've got both sides being the same trig ratio, so both of them have cosine and cosine, the angle that we apply cosine with, the x minus 20 and the 50, they should be equal. So you take off the cosine, so that x minus 20 equals 50, and so x would simply equal to 70. Okay. Now for question B, same thing. These two are not the same trig ratios, they're complementary trig ratios. We can change the one with the number, okay, to its complementary ratio. We can actually do it to the other one as well if you wanted to, but we'll just do it to the number for now. So cosine of 10 can be changed to sine just by taking the prefix co off. 90 minus that number there will give us 80. And once we've done that, we can now see that both of them have sine and sine there. So 2x should equal to 80. And that's why x equals 40 degrees once you divide it by 2. Okay. Right, let's go into question 3. So in question 3, it says here that two angles P and Q add up to 90 degrees, and sine Q, which is opposite over hypotenuse, is equal to 15 over 17. So when you draw a right angle triangle, the remaining angles here must add up to 90 degrees, because if those two add up to 90 degrees, then 90 plus 90 should give you 180 degrees in total. So these angles that they're talking about are P and Q. So P here and Q there. Okay. So that, yeah, as I said, those two are 90. plus 90 gives you 180. That makes sense. So now we have to apply, where are these sides going to be on that triangle? Sine q is opposite of hypotenuse. So opposite q is 15. So that's 15 there. Whereas the hypotenuse, according to this, is PQ, and that's 17, which basically allows us to find out this remaining side just by using Pythagoras' theorem. So we're just going to call that maybe x, okay? So x squared, the shorter side, is going to become 17 squared minus 15 squared. Okay, so 17 squared minus 15 squared is 64. So that means x is the square root of 64, which is basically 8. Okay, so once we have all three edges of our triangle, what's that going to allow us to do is find cosine, sine, and tan of each and every angle here. Okay, apart from that 90 degrees, which we don't need to do. But cosine of P, right? If you use this as the angle, cosine of P is adjacent over hypotenuse, which means 15 over 17. Okay. Whereas cosine of Q, okay, so if you use the angle here, cosine of Q will be the adjacent over hypotenuse, which is now 8 over 17. Okay. Right. In question 4, okay, we're going to learn to simplify each expression. So right over here, if you glance at all these questions, I've placed down all trig ratios which are complementary to each other. So you've got cosine, sine, cosine, and sine. Okay. So the trick is we just have to change one of them. Doesn't have to be both of them, just one of them. So I'll choose to change maybe cosine. Okay, but I'll leave this alone. Okay. So sine of 26, I'll leave alone. But if I wanted to change cosine to a complementary trig ratio, I remove co, and that will become sine again. And I do 90 minus this angle, which is 26 degrees. So now you have 26 minus 26, which is equal to 0. Okay? You can actually do the other way around and it will still work. Okay, whereas for question B, you can change any one of these. So last time I changed cosine to sine, I'll change sine to cosine this time. So I'll fix the top bit. Whereas on the bottom, I'll change sine into cosine just by adding the prefix co to it. That becomes cosine. And 90 minus 43 will be 47 degrees. So then we can cancel out the cosine 47s because they're equal trig ratios. Hence, we only have 5 left as an answer. Now, as for C, I would leave sine theta on top. Whereas on the bottom, we've got 2 cosine 90 minus theta, and we can change that into sine by removing co of this. Okay, and 90 minus theta just becomes theta, which is the complementary angle. So then you've got sine theta on top and the bottom, but you know that when you cancel everything out on the top or the bottom, in this case, this top bit here, we have to write 1. Okay, so our final answer should just be half. For question 5, it says find exact values of cosine phi, sine phi, and cosine theta if sine theta equals to root 7 and 4 and theta is 90 minus phi. Okay, so basically, well, if sine of theta equals to root 7 and 4, we can draw a triangle for that. Okay, so here's 90 degrees. Here's theta. Okay, and so we've got sine theta equals to root 7 and 4, which means this is the opposite edge, and that's the hypotenuse. So opposite theta is root 7, and the hypotenuse is 4, which is the longest side, opposite the right angle. So now what we're going to do is find anything here that applies to that. So we're not going to find cosine phi and sine phi because there's no phi there, but cosine of theta is something we can find. So we can write cosine of theta, but that's adjacent of hypotenuse, and we don't have the adjacent side here. So we'll call that x. We'll find that using Pythagoras theorem. That will be 4 squared minus root 7 squared, which is 16 minus 7, and that's 9. So that means x equals to 3 once you take the square root of it. So since x equals 3, and that's our adjacent edge, we write that over its hypotenuse. Okay, so it's 3 over 4. Okay. Whereas, if we wanted to find out cosine of phi, right? Okay, so how do we do that? Okay, so cosine of phi, okay, is not part of this triangle at the moment. There's no phi here, okay? But if I just write down, instead of theta, I write that, which is now 90 minus phi. Okay, let me write that down. So sine theta equals root 7 over 4, but I'm going to change this guy, the theta, into this. That's what it says. So that means sine of 90 minus phi is equal to root 7 over 4. So we've made theta disappear and we've replaced it with something to do with phi. But sine of 90 minus phi is going to be cosine of phi. So I've changed the sine ratio to its complementary ratio, and I've changed the angle here to its complementary angle. And that is still equal to root 7 and 4, right? So cosine of phi can be drawn like this, okay? So I can put phi here, okay? And that will be adjacent over hypotenuse, which is root 7 over 4, okay? And what do you know? That triangle is actually the same as this triangle. And you know what? It's because this angle here is basically phi, okay? Because if you rearrange this, theta plus phi equals 90 degrees. So that means this angle plus this angle, which is now phi, has to be equal to 90 degrees. Hence, we're actually dealing with the same triangle, okay? But phi is just up there, okay? So now that we have that, what is cosine of phi? Oops. So cosine of phi, oh, we actually already found, which is root 7 and 4. So we've done that. But what's sine of phi then? Sine of phi would equal to opposite, which is 3 over hypotenuse of 4. Okay?